We are a community around the Great Lakes. With that comes the responsibility of trying to maintain the lakes as best we can. Algal blooms are no different really than any kind of seasonal change that you might see on land. Well, we have a counterpart to that, seasonal blooms that happen in the ocean and in the world's large lakes. But most of these are very simple, either single-celled organisms or organisms that grow in colonies that are microscopic. The blooming species or the group of species that blooms, oftentimes their metabolism kicks up, they start to increase in abundance, and as a result of some of the biochemical reactions that happen within the cells, they release chemicals, and those byproducts have implications, usually harmful implications for vertebrates, including fish, even invertebrates, zooplankton, and they might even have health implications for humans. They're not being fueled so much by new nutrients, perhaps. They're actually sticking around because they're less edible to the dracaenid mussels that are probably eating their competition. I'm working in collaboration with NOAA, the National Oceanic and Atmospheric Administration in Ann Arbor, and we are running monthly cruises to monitor algal blooming throughout the western basin of Lake Erie. My part of the particular project that I'm working on is to actually look at the samples and identify the algal species that are present, their relative abundance, their absolute concentration. And I'm actually using certain types of incubators to provide different levels of light. And we're looking at the rate of photosynthesis relative to the amount of light. And we can use that to predict what happens during different times of the year, during different depths in the water column, and start to actually model and make calculations about the relative productivity of not just the algae on a specific date, but actually populate models that can predict annual production of phytoplankton